Alright, hi everyone. Let's continue with our data structures and algorithm series. In our previous video, we discussed about linear search algorithm and its time complexity in various cases. In today's video, we are going to discuss a better searching algorithm than linear search, and that is binary search. In binary search algorithm, we repeatedly divide the given sorted data or a sorted array into half to find our target value. Let's try to understand it with an example. As you can see, I have an array here that has 5 elements 0, 1, 2, 3, 4 and 5. Now if I ask you to find 5 in this array using binary search, then your first step will be to find the middle index of this array and divide it into half. The middle index here will be 2. And then once we divide it into two halves, one half will have 0 and 1 and the other half will have 3, 4 and 5. Now we need to find 5, right? And 5 is greater than 2 and this is a sorted array. So this is confirmed that 5 will lie in this half of the array, not in this half, right? Then we can eliminate this half and we'll continue our process with the second half. Remember, we need to repeat this process until we find our target value. Now if I ask you to find the middle index of this array, the middle index is 4 and 5 is greater than 4, meaning 5 will lie in this half of the array. So we will eliminate 3 and 4 together. And continuing with the 5, we can compare that this is our target value. And that's how binary search works. Unlike linear search, binary search eliminates half of the remaining data in one time. In linear search, you have to compare your target value with each and every element of the given array, right? If you have to find 5 in this array using linear search, you have to compare it with every other element until you find it. But in binary search, you will be eliminating the irrelevant data every time and only compare it with the relevant data. Always remember, binary search is helpful only for the sorted arrays or sorted data. If this array was not sorted, it will be hard to find our target value using binary search, because in that case we will not be able to find in which half of the array our data is present, right? If you remember, we have seen this approach in our previous videos as well, and that was our divide and conquer video, right? In divide and conquer, we have seen something similar. Divide your sorted array into halves and find out your desired value. Binary search is an example of divide and conquer pattern. Alright, now let's try to solve a problem statement to understand it properly. Here is my problem statement. Given a sorted array of n integers and a integer m, find and return the index value of m. If not found, then return -1. Here is our example array and we need to find the index value of 15. Let's see the solution of this problem statement visually first and then we will write code for it. Alright, so the first step to solve a problem with binary search is to find their min, max and their middle point. In this array, the min point will be 0th index and the maximum point will be our 12th index. And if you find their middle point will be the 6th index, right? Now remember, we need to find the index value of 15. If I compare 15 with this 6th index value, 15 is greater than 11, right? So we know that 15 lies in this part of the array, which means we can eliminate all the elements of our other half. So I am using red color for the eliminated elements. Now, as we discussed during our definition of binary search, we need to repeat this process of dividing array into halves multiple times until we find our desired value. So let's repeat our step 1. Find the min and the max and the middle point. So the new min point here will be 7th index and the max point will still remain 12. Now if you find their middle point, the middle point will be 10th index. Now if I compare 15 with 17, 15 is smaller, right? Which means 15 will be available in this part of the array. So which means we can eliminate all the elements of our other half. Let's change the color of these elements to the red, right? Now you can see we have eliminated so many elements and we don't need to compare our desired value with all these elements. Now we have left with these elements only. Let's repeat our step 1 again. Find the min and the max point and their middle point. The middle point is 8th index. Now if we see the value of 8th index, that is 15, and 15 is our desired value, right? So we have successfully found the index of our target, and that is 8. So that's how binary search is better than linear search. In linear search, you have to compare your target value with all the elements present in an array. But in binary search, we keep on eliminating the data so that we can reduce the number of comparisons. And that's how the time complexity of binary search is better than linear search. Now let's write code for it. For that, let's jump to our code sandbox. Alright, so our first step will be to define your min and max point. Min will be my 0th index and max will be my last index. Right, now we need to divide our array into two halves repeatedly. For that we will need a loop here. This loop will keep on running if our min point is smaller or equal to max point. Now to divide our array into two halves, we need to find out our midpoint, right? For that, let me define my mid variable here. I will just do a math.floor so that we do not get any decimal values. It will give us a whole number. Min plus max divided by 2. Alright, this will give us our midpoint. Now we need to compare our target value with our midpoint. If our mid value is same as our target value, then we will simply return the index. Else if our mid value is smaller than our target value, then we will shift our minimum point next to our midpoint. That will be something like, to understand this statement, let's go back to our slides. You remember 15 was greater than 11, so we eliminated all these elements, right, and moved our minimum point to the 7th index. The same thing we have done it here. Now in case your mid value is greater than m, then we will move our maximum point to next to the midpoint. Now to understand this statement, let's look at our slides. Now if you remember, when our midpoint was 10th index and we compared 15 is smaller than 17, then we moved our maximum point from 12th index to the 9th index and eliminated all of the elements from 10th index to the 12th index, right? So that we do not have to perform any unnecessary operation. Alright, I think that's all what we need to do. If we do not find our target value, we will simply return -1. Let's try to run this in our console. Alright, you can see we are getting the answer as first index because I'm trying to find 3 in this array and 3 is present at first index. Now I will find out 15, then you can see the final outcome is 8th index, which is correct. So that's all for this, and that's how binary search works and performs better than the linear search. And if we talk about the time complexity of binary search, then for best case it will be O of 1, because let's say if your target value is present at the middle point, it can be found in the very first comparison, right? And for average and worst cases, the time complexity will be O of log n. If you are not sure why O of log n, then I will recommend you to watch the O of log n video. I will paste the link in description. You can check out there how we calculated the O of log n time complexity of a given problem statement. And thanks for watching.